In our last video, we had a look at some of the formulae that we will get on the formula sheet when we write those final exams. So we'll be given our normal increasing formula, so if we invest money, and our normal depreciation formula. And then we had a look at this one in the red block that is not going to be on the formula sheet. So we need to be able to convert between effective and nominal interest rates, and this is a formula you need to memorize. Today's video is going to focus on annuities. We get two types of annuities. The first one is the future value annuity, and the other one is the present value annuity. And it's very important to know when to use which one, because we do get both of them on our formula sheet. The good news is when you think about it logically, you'll actually be able to know very easily which one to use and when to use it. So future value is something that you want to start saving towards. So you will have the money in the future. So this is normally a savings account or a retirement annuity, but you won't have the money now. You'll be saving towards something in the future. If you compare that to a present value annuity, a present value means you need the money in the present. So future value, we're saving for our future. Present value, we're borrowing money so that we can have it right now. So something like a home loan or a bond account, those are present value annuities. Okay, there are a few variables here which are, some of them will be similar and there are some new ones. So let's have a look at what each of these variables represents. Okay, in our future value annuity, X is going to be the monthly installment. So realistically, what we've been looking at in the past, although true, it's not as realistic as these annuities. Generally, if you are saving towards retirement, you save at regular intervals. And so this would be monthly installments, or in fact, it's not always monthly. It's however often you make those installments. But that's the amount of money that you pay at a regular interval. So there could be quarterly installments, but the point is they are the installments that you pay off. Okay, I is your interest rate, and that's an annual thing. And the reason why I point that out is just because if it's per annum and you are given a monthly installment, you're going to need to, a monthly interest rate, you're going to need to divide. Okay, so just bear in mind there you may need to divide by the number of compoundings. And then N is the number of installments that you will make. And so basically, if you are saving on a monthly basis for your retirement, you will take the number of years that you are saving for times by the months in the year or something like that. And that's how you'd get that N value. Okay, it's very similar for a present value. So X is the installment amount. In other words, how much are you paying off every month? I is that interest rate, again, per annum. Remember, that means a yearly thing, so you'll need to adapt it. And then N is the number of time periods that we'll take to repay the loan. So if we're paying it off over 10 years and we're paying it off quarterly, we will have 40 payments that we make. Okay, the best way to work with annuities is to actually put them into some practical examples. So why don't we do that now? Neo is going to buy a house for 1.25 million rand. The bank offers him a 90% bond with an interest rate of 11.5% per annum compounded monthly. And then we've got 3 questions here to answer. How much deposit will Neo have to pay? What will his monthly installments be if he pays the loan over 20 years? And then Neo looks at his budget and decides that he can afford to pay 13,500 Rand towards his bond each month. How long will it take him to pay the house off? Okay, so I think what we're doing here is we're going to compare what's the minimum monthly installment here in question 2, and then question 3 is going to look at what happens if we pay a little bit more. How long will it take us to repay this house? Okay, let's look at the first 2 questions. Question 1 is super straightforward. How much deposit will Neo have to pay? Well, the bank has offered to give him a 90% bond, which means that he's going to need to have a 10% deposit to put down on this house. So 10% of the 1.25 million, and we can calculate that quite easily, and we get an answer of 125,000 Rand. Okay, so he's going to have to bring this 10%, and then the bank is going to give him the loan for the other 90%. Okay, now what will his monthly installments be if he pays the loan over 20 years? So the first question we need to ask ourselves is, are we talking about a future value or a present value? Okay, because he needs the money now, he is definitely working with a present value annuity. Loans are present value annuities. So there's our formula for the present value annuity. Let's work out what each of these elements means. Okay, so present value, how much money does he need to borrow? Well, the house is worth 1.25 million, but he is going to pay this 125,000 Rand off. So that means he borrows 1.125 million Rand. Okay, that's the first thing. X, what they've asked us for is his monthly installments. So that means they want this X value. Okay, so I don't know what that is, but I and N I can most certainly try to figure out. So let's have a look. I is the interest rate, and it's an annual thing. So 11.5%, but it's compounded monthly. So I take that 11.5 and I put it over 12 because of the monthly, and I divide by 100 because it's a percentage. So 11.5 divided by 1,200 is what I will substitute into my formula. And remember with these things, it's so easy to lose marks if we start rounding off. So leave it in that fraction form, and we'll only round off our final answer so we don't miss out on any marks. Okay, and then finally N, how many installments is he going to make? Well, they tell us in the question that he's going to pay the loan over 20 years, and he's doing monthly installments. So there are 12 months, and he's going to pay off over 20 years, so 240 installments in total. So with this information now, I am able to substitute into the formula, and then we can assess what we still need, if we still need anything, or if we can work things out. So 1,125,000 is equal to X multiplied by 1 minus 1 plus the interest there. We said it was going to be 11.5 over 1,200 to the power of minus 240. And then all of that divided by the interest, 11.5 over 1,200. That's our formula. Okay, now I need X on its own. But if you have a look closely, you'll see that X is currently multiplying by all of this. So what we can do is we can divide both sides by that value, and that will give us X on its own. Okay, and if we can do it all in one step, we also then have the benefit of no rounding off until our final answer. Right, so if we look at it now, that whole fraction will cancel with that whole fraction, and then all I need to do is just calculate very carefully, and I'm left with X on its own, and that will give me my monthly installments. So let's punch that into the calculator, and we'll get a neat answer for X. So there we have it. His monthly installments are going to be 11,997 Rand and 33 cents. Remember that regardless of what the question says, we round off to 2 decimal places, because when working with money, that's how it works. We give our answer in rands and cents, and we've written the rand here. The minute we put the comma, that indicates cents. It's not necessary to add another little C there on the end. Okay, let's have a look at that next question that said, well, what happens if he pays a bit more? So have a look at this. This is paying off almost 12,000 Rand a month, and it's going to take him 20 years. Let's go and work out how long it'll take him if he pays off a little bit more. So here's the information we already know. He's going to still do the deposit, so he still needs 1.125 million. The interest rate is unchanged, but now we want to know the value of N if his X value is 13,500. So X is equal to 13,500, and then N we can leave as N, but remember, because it's monthly, it's like N years times 12. So let's rather call it 12N. Every month times the number of years. Okay, now let's take a look at what happens when we input all of this stuff and how we solve this question. So the P here is 1,125,000 equals 13,500, 1 minus 1 plus, there's our interest rate, 11.5 over 1,200 to the power of minus 12N now, because we don't know exactly what that's going to be. And then all of that divided by the interest rate, 11.5. 5 over 1200. Okay, now it's a little bit of a different solve for us, but that's okay. What we can do for starters, we want to try and get this part here on its own. Okay, but because it's in a bracket, we're going to leave the bracket here for now, and all that we're going to do is we're going to divide by this. And what I do to the one side, I do to the other side. So I'm going to punch into my calculator 112,500 divided by 13,500 over 11,5 over 1,200. Okay, if you check on your side, you should also be getting this answer, 115 over 144. Okay, and that is equal to 1 minus, and then this other bracket, which if you punch that into your calculator, 1 plus 11,5 over 1,200, you get an answer of 2423 over 2400. Okay, and that is to the power of minus 12n. Okay, now I'm going to switch some things around. This negative bracket, I'm going to move over so that it becomes a positive bracket. Okay, so it's going to be 2423 over 2400 to the power of minus 12n is equal to, and then this other side is going to become 1 minus this fraction here. Okay, so that equals 29 over 144. And now we need to think back to our last video. If we want to know the unknown, or if the unknown is an exponent, we can then use logs. So we can say minus 12n is equal to log, the base stays the base, so 2423 over 2400, and then of the number 29 over 144. Okay, and that's going to give us an answer there. So minus 12n is equal to, let's work that out. Okay, so then we have minus 12n is equal to minus 168 comma something. We don't round off yet because it's not our final answer. We need to divide both sides now by minus 12. Divide by minus 12. And that's now going to give us a final answer here of n is equal to, let's see, divided by minus 12. On my calculator, I get 14,00, so I think it's safe enough to say that is 14 years. Okay, take a moment. This is what I love about financial maths, is that we can then think about it. So Neo was paying off, remember what we said in the previous question, 12,000 Rand a month was going to take him 20 years to pay. If he simply adds another 1,500 Rand a month, he reduces his payment term by 6 years. And this is the thing about bonds, is that the more money we can push into them, the more money we will save, or the less interest we will have to pay at the end of the day. Here's another example. John has started a new job and decides to start saving for retirement. He plans to save 800 Rand every quarter. The bank offers him an interest rate of 12% per annum compounded quarterly. How long will it take him to save 1 million Rand? Okay, so this is a future value. John is working now to save money for his future. Let's pop the formula down and then we can start to fill things in. Okay, future value, what we want is 1 million Rand, or what John wants is 1 million Rand. X is the monthly installment, and it's not monthly, sorry, it's a quarterly installment. So he's going to be paying 800 Rand every quarter. Okay, we're going to apply the quarter. It always goes to the I and the N. Okay. Interest rate is 12% per annum, also compounded quarterly. So we're going to take the 12% and we're going to divide it quarterly and put it over 100 so that it's a percentage. And then N, how many time periods? Okay. We're not sure, but we know they're going to be compounded quarterly. So 4N is what we're going to use for now. And then we are going to aim towards solving for N. All right, so let's substitute into the formula and we see what we are dealing with. So 1 million is equal to, there's his little installment, 1 plus I is 12 over 400. And all of that is raised to the power of 4n minus 1. This is going to be quite similar to the one we just did in terms of how we can solve it. Okay, and then divided by, again, 12 over 400. Okay, so our goal is to work towards isolating the thing we need to work out, which is here. But at the moment, it's part of this whole bracket. So what we're going to do is we're simply going to divide by this part of the fraction. And what I do to the one side, I do to the other side. So on my calculator, I type in 1 million divided by 800 over 12 over 400. And then I get a nice little answer there of 75 over 2 is equal to 1 plus, let's work out this bracket. So instead of the whole 1 plus 12 over 400, we're just going to say 103 over 100. That's to the power of 4n minus 1. Okay, let's move this minus 1 across. It's going to become plus 1 on that side. So 75 over 2 plus 1 takes us to 77 over 2. And that is equal to 103 over 100 to the 4n. Okay, and now we're going to use logs. Logs are going to help us because our unknown is up there in the exponent. So the log says we can make that the subject of the equation. If we log the other side, the base stays the base, and then the number is that 77 over 2. So let's work that out on our calculator. So we get 4n is equal to 123,5049 ... Remember, we don't round off because we're not finished yet. We still need to divide both sides by the 4. So we get n equal to 30,8762. And then we just take a look at the question to make sure that we round off properly. Okay, they want to say, how long will it take for John to save 1 million rand? Okay, they didn't specify there to round off to the nearest year. So that means we're allowed to then give our answer to 2 decimal places. So 30,88 years. If they had asked us to round off, because they like to do this in this section, we'd actually have to say 31 years. Okay, even if this was a very low decimal, we'd still have to say if he only saved for 30 years, he wouldn't quite make the million mark. So we'd have to round up to 31 years.